Breaking news tonight as quantum AI scans have confirmed that interstellar object 3I Atlas is not natural at all. At first, 3 Atlas seemed harmless, gliding silently through the solar system. But new data shows Atlas has shifted course. Its new path could put it on a direct collision course with Earth. If true, we're staring at the kind of impact that doesn't just damage cities, but wipes out civilization itself. Could this be the end of humanity? Are we truly prepared for the unthinkable? Or is there something more behind this sudden change? Numbers don't lie. The universe just dropped something impossible into our backyard. And the math is breaking scientists' brains. 3 Atlas, an interstellar object roughly 20 kilometers across, represents such a statistical nightmare that astronomers are questioning everything they thought they knew about how space works. The probability calculations alone tell a story that makes no sense under natural circumstances. Think about what interstellar space actually contains. Between star systems, you find almost perfect emptiness with the occasional dust particle floating around. Based on decades of sky surveys, encountering a 20-kilometer object from interstellar space should happen maybe once every 10,000 years. Yet, here we are, just a few years after spotting our first interstellar visitors, staring at something hundreds of times bigger than anything we've seen before. The detection setup makes this even weirder. Modern telescopes photograph the same sky patches repeatedly, looking for objects that move between frames. These systems are calibrated for objects moving at typical solar system speeds. 3 Atlas moves twice as fast as anything humans have ever launched, yet it still shows up perfectly in our detection range. Something moving much faster would just appear as a blur in a single frame, making it impossible to track. What's particularly striking is how 3 Atlas emerged from the cosmic shadow. The object approached from a direction in the sky packed with so many stars that it remained hidden until July 1st, 2025. This crowded stellar background acted like natural camouflage, concealing the object until it reached just the right position for our telescopes to distinguish it from the background stars. The timing seems almost deliberate, as if the object wanted to remain undetected until a specific moment. The progression from our first discoveries makes zero sense. 1 IWAM was small and elongated. Toei Boris looked like a normal comet. Now, 3 Atlas appears absolutely massive compared to its predecessors, following a trajectory that seems almost perfectly planned. If these objects were randomly scattered through space, we should see predictable size distributions with smaller ones being way more common. Instead, we jumped from pebbles to a mountain with nothing in between. The perfect tour route. Here's where things get really strange. This object isn't just wandering randomly through space like you'd expect from a chunk of rock that got kicked out of some distant star system. 3 Atlas is following what looks suspiciously like a carefully planned route that hits all the major destinations in our solar system. The trajectory aligns within 5 degrees of the ecliptic plane, where all our planets orbit the sun. Think about this for a second. Random interstellar objects can arrive from literally any direction in 3-dimensional space. The chances of one just happening to align with our planetary highway are about 1 in 500. That's already pretty unlikely, but it gets way more suspicious when you look at where this thing is headed. As 3 Atlas cruises through our neighborhood, it's going to pass remarkably close to Mars, Venus, and Jupiter. When scientists ran the numbers on what it would take for a random trajectory to bring an object this close to 3 different planets, they got odds of 1 in 20,000. These aren't impossible numbers, but they're definitely the kind that make you scratch your head and wonder if something else is going on. The object moves in what astronomers call a retrograde orbit, meaning it's traveling opposite to the direction our planets circle the sun. For a random space rock, this wouldn't be particularly weird. But if you were designing a probe to get the best possible look at multiple planets while using the least amount of fuel, a retrograde orbit would be exactly what you'd choose. It gives you extended observation time as you approach each world, pass by, and then recede into the distance. Here's the kicker, though. 3 Atlas will reach its closest point to the sun on October 29, 2025. And guess where Earth will be at that exact moment? On the complete opposite side of our star, during the object's most vulnerable time, when it's getting blasted by intense solar radiation and heat. It manages to avoid the one planet in our solar system that's absolutely crawling with intelligent life. That's either an incredible coincidence or very deliberate planning, broken comet rule. NASA has officially labeled 3 Atlas as a comet and assured everyone it poses no threat to Earth. But there's a problem with that classification. This thing refuses to behave like a comet should, and the differences are becoming harder to ignore. Comets are basically dirty snowballs that start acting up when they get close to the sun. Solar radiation heats their surface, causing ice to turn directly into gas in a process called sublimation. This creates pressure that pushes material away from the comet's core, forming the beautiful tails we see in pictures. The whole process is so predictable that astronomers can calculate exactly when and how much a comet should brighten as it approaches our star. But 3 Atlas isn't playing by these rules. The Hubble Space Telescope took detailed pictures of the object, and instead of seeing the expected tail streaming behind it, astronomers found something completely different. There's an unusual glow surrounding the object. But here's the weird part. This glow actually precedes the object toward the sun rather than trailing behind it like a proper comet tail should. This is backwards from everything we know about how solar radiation affects natural objects in space. When the sun heats up a comet, the resulting gas and dust get pushed away from the sun, not toward it. What 3I Atlas is displaying looks more like some kind of active emission or debris field moving ahead of the main body that suggests either a completely new natural process that nobody has ever seen before or artificial propulsion of some kind. The brightness characteristics also don't make sense for a normal space rock. Most objects reflect sunlight in predictable ways based on what they're made of and their shape. The light patterns coming from 3 Atlas suggest either an unusually reflective surface or some kind of artificial lighting contributing to what we're seeing. Neither explanation fits comfortably with the idea that this is just another comet. The real test comes as 3 Atlas gets closer to the sun over the next few months. If it's really made of ice and rock like NASA claims, it should start erupting with gas and dust, creating the spectacular tail that all comets develop when they get heated up. If that doesn't happen, if it continues showing this weird forward-directed glow instead of proper comet behavior, then we'll know we're looking at something genuinely anomalous. The size problem. The sheer size of 3I Atlas creates what scientists are calling a scaling problem that breaks their understanding of how stuff moves through interstellar space. Rocky material between star systems is incredibly rare, scattered so thinly that encountering large objects should be extraordinarily uncommon events. To put this in perspective, interstellar space contains roughly 1 atom per cm. That's already pretty close to a perfect vacuum. Rocky material makes up an incredibly tiny fraction of that already sparse density. The natural processes that could eject a 20-kilometer object from another star system and send it flying through space at interstellar speeds are catastrophically violent events like supernova or massive planetary collisions. These kinds of cosmic disasters don't happen very often, and when they do, they scatter debris in predictable patterns. Based on what astronomers know about the frequency of these events and the density of rocky material in interstellar space, we should see an object the size of 3I Atlas, maybe once every 10,000 years or longer. Instead, we're looking at our third interstellar visitor in just a few years, and it's absolutely massive compared to the first two. The energy requirements for accelerating something this big to interstellar velocities are also problematic. Natural gravitational slingshot effects from massive objects like stars or black holes could theoretically provide enough energy, but encounters that violent would leave unmistakable signatures. Large rocky bodies subjected to such extreme forces typically break apart into smaller pieces, rather than maintaining their structural integrity. Yet 3 Atlas appears remarkably intact and cohesive. There's no evidence of the chaotic tumbling or irregular rotation you'd expect from an object that got violently ejected from another star system. It's not showing signs of fragmentation or significant surface damage that should result from millions of years traveling through the harsh environment of interstellar space. The thermal history is another puzzle. Spending potentially millions of years in the near absolute zero environment between stars should create specific changes in crystalline structures and surface weathering patterns. When astronomers get detailed spectroscopic data from 3I Atlas, they'll be able to tell whether its composition matches what they'd expect from an ancient space wanderer or if it shows anomalies suggesting a different origin entirely. The technology question. Harvard astrophysicist Avi Loeb has created what's now called the Loeb scale specifically to deal with situations like this. It's a 10-point system for evaluating how likely it is that an object represents extraterrestrial technology rather than a natural phenomenon. 0 means definitely natural, like a regular comet or asteroid. 10 means definitely artificial, something that maneuvers, broadcasts signals, or shows other clear signs of being built by an intelligence. Right now, Loeb ranks 3I Atlas as a 4 on this scale. That means there's substantial evidence suggesting it might be technological, but not enough yet to be certain. This ranking reflects the multiple weird things about the object that individually might have natural explanations, but collectively start looking like artificial design. The mathematical precision of the trajectory, the unusual size compared to previous discoveries, and the behavioral deviations from expected comet activity all contribute to bumping it up the scale. Modern detection technology gives us unprecedented opportunities to figure out what we're really looking at. Radio telescopes can listen for electromagnetic emissions that might indicate active communication systems or power generation. Infrared detectors can measure heat signatures that could reveal internal energy sources beyond simple solar heating. Even gravitational wave detectors might pick up subtle variations in spacetime caused by exotic propulsion systems. The crucial test will come as 3I Atlas approaches the Sun over the next few months. Natural objects made of ice and rock have to respond predictably to solar radiation. They heat up, they start out gassing, they develop tail, and they show specific changes in brightness and spectral characteristics. If 3I Atlas fails to display these expected responses, it moves significantly higher on the technological probability scale. Advanced extraterrestrial technology might use materials and propulsion methods that operate way beyond our current understanding. Controlled nuclear fusion, exotic matter manipulation, or electromagnetic field generation could explain the unusual emission patterns astronomers are seeing around the object. Such technologies would leave detectable signatures across the electromagnetic spectrum and in gravitational measurements. There's also the question of the object's apparent avoidance of Earth during its closest approach to the Sun. This could be a remarkable coincidence, or it could represent deliberate mission planning designed to minimize interaction with a potentially reactive technological civilization while maximizing scientific data collection from multiple planetary targets. Academic blindness. The scientific establishment's response to unconventional ideas about 3 Atlas reveals some troubling problems with how modern research actually works. Academic culture has slowly transformed into a system that rewards playing it safe rather than pursuing groundbreaking discovery. Too many scientists spend more time worrying about what their colleagues think than focusing on what the evidence might be telling them. The funding structure creates perverse incentives where the same people who might disagree with your revolutionary ideas are also the ones who decide whether you get money to continue your research. It's like asking a food critic who hates spicy cuisine to fund your experimental hot sauce laboratory. The system naturally pushes researchers toward boring incremental work that won't upset anyone important in their field. Universities have also become increasingly politicized, which creates additional barriers to genuine scientific inquiry. When institutions start leaning heavily toward particular ideological positions, they risk developing blind spots that affect how researchers approach controversial topics. Science functions best when it stays focused on evidence and data rather than getting tangled up in political considerations that have nothing to do with understanding how the natural world works. The peer review process, which was originally designed to maintain quality standards, has evolved into something more like intellectual gatekeeping. Reviewers often evaluate research proposals based on how well they conform to existing theoretical frameworks, rather than their potential for genuine discovery. This creates a vicious cycle where only safe, predictable research gets funded, while truly innovative ideas get dismissed before they can be properly investigated. Historical examples show just how damaging this conservative approach can be. Quantum mechanics completely revolutionized physics, but it faced enormous resistance when it was first proposed because the ideas seemed too strange to be true. Even Albert Einstein had trouble accepting some aspects of quantum theory, which shows that even brilliant minds can get trapped by their own preconceptions about how reality should work. The current reward system makes these problems even worse. By focusing on publication numbers and citation counts rather than genuine innovation, researchers build their careers by producing lots of papers that reference each other's work, creating echo chambers where the same ideas get recycled endlessly. This approach actively punishes the kind of bold outside-the-box thinking that leads to major scientific breakthrough. Cosmic reality check. The mathematical reality of intelligent life in the universe makes humanity's assumption of cosmic uniqueness look completely absurd. Our galaxy alone contains roughly 1 billion stars, and many of them host planetary systems that could potentially support the development of complex life. Claiming that none of these billions of worlds ever produced intelligent civilizations is like walking down a street full of houses that look just like yours, and insisting that none of them have any residents living inside. The timeline argument makes our cosmic arrogance even more ridiculous. Our Sun formed only 4.6 billion years ago, while the universe itself has been around for 13.8 billion years. This means our solar system is relatively young in cosmic terms, arriving on the scene long after many other star systems had already existed for billions of years. Any civilizations that developed around those older stars would have had enormous head starts on technological development. The earliest generations of stars contained only hydrogen and helium, lacking the heavier elements necessary for rocky planet formation and biological chemistry. But successive rounds of stellar death and birth gradually enriched interstellar space with carbon, oxygen, silicon, and other elements essential for life as we understand it. This cosmic enrichment process reached sufficient levels for Earth-like planets to form several billion years before our own solar system even existed. To put the exploration timescales in perspective, consider that one of our current spacecraft would need less than 1 billion years to cross the entire Milky Way galaxy. Civilizations that got even a billion-year head start on technological development would have had plenty of time to explore every corner of our galaxy, including our little neighborhood around the Sun. They wouldn't need impossible faster than light travel or magical physics. Just steady technological progress over the kind of vast timescales that the universe routinely provides. This cosmic perspective completely transforms the fundamental question we should be asking. Instead of wondering whether intelligent aliens exist somewhere out there in the vastness of space, we should be asking whether we're smart enough to recognize them when they show up in our own backyard. The assumption that advanced civilizations would necessarily make contact according to human expectations reflects a profoundly self-centered worldview that might blind us to more subtle forms of interaction. September deadline. The clock is ticking toward what might be the most important deadline in human history. By the end of September 2025, we should have a definitive answer about what 3I Atlas really is. The observation window is brutally short because in October the object will disappear behind the Sun's glare, making detailed study impossible until it emerges on the far side months later. Aviv expects the answer to come with mathematical certainty. If 3II Atlas consists of ice and rock like a traditional comet, solar heating will trigger massive outgassing events that create the spectacular tail astronomers have been waiting to see. But if those characteristic eruptions never materialize, if the object continues displaying its mysterious forward-directed glow instead of proper cometary behavior, the implications will be staggering. A 20-kilometer artificial object passing through our solar system would represent technology so far beyond human capabilities that it might as well be magic. The observational challenges during this critical period highlight just how difficult space-based astronomy can be. Ground-based telescopes have to deal with atmospheric interference, weather conditions, and the Earth's rotation, which limits how long they can observe any specific object. Space-based instruments like the Hubble Space Telescope offer much better image quality, but they operate under extremely tight scheduling constraints with observation time typically booked months or years in advance for approved research program. The Galileo project, which Lowe leads, has positioned specialized observatories across the United States, specifically to monitor for technological signatures during and after 3I Atlas completes its passage around the Sun. These facilities use machine learning algorithms to analyze every object they detect, searching for outliers that don't match natural patterns. Lowe has instructed his team to watch particularly carefully during late October for any unusual activity in Earth's atmosphere that might indicate the deployment of smaller probes or reconnaissance craft. If 3I Atlas proves to be artificial, it will mark the beginning of a completely new chapter in human development that could either bring our species together around the shared reality of cosmic citizenship or fragment us along ideological lines that prevent any coherent response to the greatest discovery in our history. The coming weeks will determine which future awaits us and whether we have the wisdom and maturity to handle the possibility that we may have been like children playing alone in a universe filled with civilizations far beyond our current understanding. So what did you think of this latest video on 3I Atlas? Let us know in the comments down below. And don't forget to like and subscribe for more quality content.